Hi kids, so in this video we'll discuss numericals from current electricity class 10 from Concise Physics. This is exercise 8a. Look at the first numerical, what they've given. In a conductor, 6.25 multiplied by 10 to the power 16 electron flow from its end A to B in 2 seconds. Find the current flowing through the conductor and charge on an electron is given as 1.6 multiplied by 10 to the power minus 19 coulomb. First write the information. Number of electron is 6.25 multiplied by 10 to the power 16. Time they have given as 2 seconds. And charge on an electron they have given as 1.6 multiplied by 10 to the power minus 19 coulomb. They need the current. Now look over here. Current is total charge by time, which is equal to, now total charge is number of electron multiplied by charge on one electron by time. Substitute the value. That's 6.25 multiplied by 10 to the power 16 multiplied by 1.6 multiplied by 10 to the power minus 19 by 2. And this will be ampere. Yes or no? So to 1 time to 0.8 times. So 6.25 multiplied by 0.8 gives you 5. 10 to the power 16 multiplied by 10 to the power minus 19 gives you 10 to the power minus 3 ampere. Yes or no? And this is what? 1 milliampere is 10 to the power minus 3 ampere. This is 5 milliampere. That's your answer. Now, the electron flows from A to B, which means the direction of the current will take is from B to A. So, this much current flows from B to A. Am I clear? Yes, that's the answer. 5 milliampere from B to A. Done. Very easy. Just use this formula. Now look at sum number 2. Now look at number 2. A current of 1.6 milliampere flows through a conductor if charge on an electron is minus 1.6 multiplied by 10 to the power minus 19 coulomb. Find the number of electron that will pass each second through the cross section of that conductor. Each second. Isn't it? Now look away. Just now we did. Current is Q by T. Current is number of electron multiplied by charge on one electron by T, which means number of electron over here becomes I multiplied by T divided by E. Yes or no? Now milliampere to ampere, just now we multiplied by 10 to the minus 3. Yes or no? Now substitute the value. So N is I is 1.6 multiplied by 10 to the minus 3 multiplied by T is 1 by E. I'm taking positive because number of electron can't be negative. So 1.6 10 to the minus 19. Yes or no? Just simplify it. So this goes up. So 10 to the power 16 remains when you solve it, which means number of electron will be 10 to the power 16. Yeah, that's the answer. The number of electron that will pass each second through the cross section of that conductor is 10 to the power 16. Now let us do sum number 3. Now look at number 3. Find the potential difference required to flow a current of 200 milliampere in a wire of resistance 20 ohm. Very easy. We know Ohm's law. V equals to IR. So just substitute the value. First change this to ampere, SI unit. So that's 200 multiplied by 10 to the power minus 3 ampere. Yes or no? Substitute the value. 200 multiplied by 10 to the power minus 3 and this is 20. So this is 200 into 20 by 10 to the power 3. 10 to the power 3 is nothing but 1000. 1000, 1, 2, 3, 0 goes away. Which means 4 volt. Yes or no? Yeah. So the answer will be 4 volt. The potential difference is 4 volt. Done? Very easy. Just use the law, that is Ohm's law. V equals to IR. Now look at number 4. Enough space, we'll do it over here only. An electric bulb draws 1.2 ampere current, 1.2 ampere current at 6 volt. Potential difference is 6 volt. Find the resistance of the filament of bulb while glowing. Again, same logic. According to Ohm's law, V equals to IR, which means V by I equals to R. So 6 by 1.2 equals to R. Yes or no? That comes 5 times. So R is 5 ohm. That's my answer. In both the sum, we have used Ohm's law, that is V equals to IR. Now let us look at number 5. Now look at number 5, what they've given. A car bulb connected to a 12 volt battery draws 2 ampere current, when glowing. What is the resistance of the filament of the bulb? Very easy. We use Ohm's law, V equals to IR, which means R equals to V by I. Substitute the value, that is 6 ohm. Yes or no? So your resistance is 6 ohm. Now, will the resistance be more, same or less when the bulb is not glowing? So when the bulb is not glowing, of course the resistance will be less. Yes or no? Sure. We'll do number 6 over here only. Calculate the current flowing through a wire of resistance 5 ohm, connected to a battery of potential difference 3 volt. They need the current. Same logic, V equals to IR, Ohm's law, which means I equals to V by R. So I equals to 3 by 5. So I equals to 0.6 ampere. Yes or no? Very easy. Simple use of V equals to IR, nothing more. Let us do number 7. Now look at number 7. In an experiment of verification of Ohm's law, following observation were obtained. Potential difference in volt, current in ampere. When the potential difference was 0.5, current is 0.2, 1.0, 0.4, like this, they have given the reading. Draw a VI graph and use this graph to find. There are 3 things they told us to find. First of all, draw the graph. Now suppose we draw this axis. This is your x-axis, this is your y-axis. We'll take this as potential difference and this is current. Now current, suppose this is 0.2, 0.4, 0.6, 0.8 and this is 1.0. And this is V, 0.5, 1.0, 1.5, 2.0, 2.5. Now we plot the point. 0.5, it's 0.2. 1, it's 0.4. Yes or no? Look carefully. Then 0.6 and 1.5 over here. 0.8, 2.0 over here somewhere. Then 2.5, it's 1. Like this. So when you join all these points, you're getting a straight line like this. Now what they've asked? They've asked the potential difference V when the current I is 0.5 ampere. 0.5 ampere. See, 0.5 ampere, between 0.4 and 0.6. So suppose this is your 0.5. So from here we'll draw a line parallel to the x-axis. It meets the line over here. Drop a perpendicular from there. Somewhere in between 1 and 1.5, which means 1.25, isn't it? So this is your answer corresponding to 0.5 ampere. The potential difference is 1.25 volt. Now the current I, when the potential difference V is 0.75 volt, when the 0.75 volt, yeah, when the potential difference is 0.75, what is the current? 0.75 is between 0.5 and 1, isn't it? So we'll draw a line parallel to y-axis. It meets the curve over here. Then draw a line parallel to x-axis like this. So this is 0.3 if you look carefully, between 0.2 and 0.4. If you do it in the graph, exact reading will come. This will only come 0.3 ampere. Next, the resistance in circuit, very easy. V equals to IR. R equals to V by I. Yes or no? So when your potential difference was 0.5, your current was 1. So that's 2.5 ohm. You take any point, no? Same answer will come. Yes or no? That's 2.5 ohm. Very easy. Draw the graph properly in the graph paper, okay? Take the scale properly. Now look at number 8. Two wires of same material and same length have radii 1 mm and 2 mm respectively. Compare the resistances and the specific resistance. Look over here. There is your wire 1. There's one more wire 2. Same material. Okay? And the length of both the wires are same, but the radius, is different. Over here you have the first wire is 1 mm and the second wire, the radius is 2 mm. Compare the resistance and the specific resistance. Now specific resistance, when we talk about rho 1, rho 2. Now specific resistance depends on the material of the wire. These two are made up of the same material, which means rho 1 and will be equal to rho 2, which means rho 1 by rho 2 is equal to 1, which means the ratio of the specific resistances will be 1:1. Very easy. Yes or no? Now they have asked, this was part 2 I believe. Part 1 they have asked the ratio of their resistance. Now we know resistance is rho L by A, where A is the cross-section area of the wire. So R1 is equal to rho L. A will be pi R1 square. Circle. Now similarly R2 will be rho L pi R2 square. Rho will be same, L will be same because same length, same material. Now find rho R1 by R2. Just divide both. Let us see what happens. So R1 by R2 is equal to rho L pi R1 square multiplied by, division becomes multiplication, pi R2 square rho L. Solve it. Rho L, pi cancels. R2 square, R2 is 2. So 2 square is 4. R1 square, 1 square is 1. Which means the ratio of the resistances will be 4:1 and the ratio of the specific resistance will be 1:1 because specific resistance depends upon the material and the material is same. Done? Chalo. We'll do number 9. Now look at number 9. Very important sum. A given wire of resistance 1 ohm is stretched to double its length, what will be its new resistance? What happened? There was a wire whose resistance was 1 ohm. You stretch it to double its length. Then what will be the new resistance? Suppose L1, the length of this is L, then L2 is twice L. Suppose A1 is A, then A2 will be A by 2. Remember this, when you increase the length twice, then the area becomes half. Remember that, the cross-section area becomes half. Now look carefully. R1 is equal to rho L1 by A1. R2 equals to rho L2, now L2 is twice L, by A2, that's A by 2. So 2 goes up. The formula is rho L by A. Yes or no? Rho will be same because it's the same material. Now divide these two. R2 by R1. This is 4 times rho L by A divided by rho L by A. So that's 4 times rho L by A multiplied by rho L. Rho L, A cancel, which means 4. Which means R2 is 4 times R1. Now R1 is given as 1 ohm. So when you stretch it to double its original length, then the resistance increases 4 times. 4 ohm. Done? Let us look at the next sum now. Let us look at number 10, what they have told. A wire of resistance 3 ohm and length 10 centimeter is stretched to length 30 centimeter, which means length was 10 centimeter, you stretch it and the length becomes 30 centimeter. Okay? And the resistance was given as 3 ohm when the length was 10 centimeter. Assuming that it has a uniform cross section, what will be the new resistance? Which means they asked R2. Now this was your wire of length 10 centimeter. You triple it. The length becomes 30 centimeter. Then if the area is A, then over here area will be A by 3. That you need to know. Yes or no? Because the volume is same too. Volume is what? Length into area, that is constant. So 10 into A is 10A. 30 into A by 3 is again 10A. The volume has to be constant. Now look carefully. What they've asked? R2. Simple. R1 equals to rho L1 by A1 and R2 equals to rho L2 by A2. Just divide these two. So R2 divided by R1 is rho L2 by A2 divided by rho L1 by A1. Simple calculation. This by this. This is rho L2 by A2 multiplied by A1 by rho L1. Rho cancel. Substitute the value. L2 is 30. A1 is A. A2 is A by 3. So A by 3. 3 goes up. And L1 is 10. Yes or no? Just substitute the value. A cancels out. 0 cancels out. So that's 9. 0 means 10 1 times. 10 3 times. 9. So R2 by R1 is 9. Which means R2 is 9 into R1. R1 is how much? 3. So 9 3s are 27 ohm. So when you increase the length 3 times, the resistance increases 9 times. 3 9s are 27. Done. Now let us look at number 11. Now look at number 11. A wire of resistance 9 ohm, a wire of resistance 9 ohm having length 30 centimeter is tripled on itself. What is the new resistance? Tripled in itself, which means the new length, try to understand, tripled itself means the new length is 10 centimeter. tripled on itself, So if area is A1 is A, then A2 will be thrice of A. I told you the volume is constant. 30A, 30A. Yes or no? Because the volume does not changes. There was this wire, tripled on itself, Okay. Now, what is the new resistance? Same logic, R1 is equal to rho L1 by A1. R2 equals to rho L2 by A2. Just divide. R2 by R1 is rho L2 by A2 divided by rho L1 by A1, which is rho L2 by A2 multiplied by A1 rho L1. Rho cancels out. L2 is 10. A1 is A. A2 is thrice of A. And L1 is 30. Yes or no? This. So 1 by 9. So R2 equals to 1 by 9 into R1. R1 was 9. So 1 by 9 into 9. That's 1 ohm. So the resistance becomes 1 ohm when it is tripled on itself. Okay. Now let us look at number 12. Now look at 12. What length of the copper wire of specific resistance 1.7 multiplied by 10 to the power minus 3 ohm meter and radius 1 mm is required so that its resistance is 1 ohm? Very simple. First of all, 1 millimeter, which means 1 multiplied by 10 to the power minus 3 meter. Change it to meter, SI unit. Now we know resistance equals to rho L by A. So L equals to R into A by rho. So L equals to R is how much? 1. A. Area. Area means pi r square. Pi r square because it's circle by rho. Rho is what? 1.7 multiplied by 10 to the power minus 8. So L will be 1 into, this is 22 by 7 multiplied by r square. R square, which means 1 into 10 to the power minus 3 whole square by 1.7 multiplied by 10 to the power minus 8. Simplify it. I'm not doing it. You'll get the answer as 184.7 meter. Solve it. This was the logic. You just need to make L the subject. L equals to R into A by rho. The value of R is given, the value of rho is given, and radius is given. So area is what? Pi r square. So put the value, get the answer. Done. Now look at sum number 13. Now look at number 13. The filament of a bulb takes a current 100 milliampere when the potential difference across it is 0.2 volt. When the potential difference across it becomes 1 volt, so when it becomes 1 volt, the current becomes 400 milliampere. Calculate the resistance of filament in each case and account for the difference. First of all, over here we know V equals to IR. So R equals to V by I. V is 0.2. I is what? Now change this to ampere. So 100 into 10 to the power minus 3 ampere. Milliampere to ampere, you multiply by 10 to the power minus 3. So 100 multiplied by 10 to the power minus 3. So that is 0.2 multiplied by 10 to the power 3. This goes up by 100. This is cancels. 10 remains over here. So that's 2 ohm. Yes or no? 10 to the power 3, that's 1000 and that's 100. So 10 left. Similarly, R2 is V2 by I2. V2 is 1. I2 again 400 multiplied by 10 to the power minus 3. Because we need to change it to ampere. So that's 1000 goes up by 400. That's 2.5 ohm. Now you see, when the current is more, then the resistance is more. They've asked, calculate the resistance of filament in each case and account for the difference. Because see what happens, when the current is more, due to Joule's heating effect, the heat produced will be more. So the temperature will be more in this case. T2 will be more than T1, the temperature. And with the increase in temperature, the resistance also increases. Yes or no? So it increases because the temperature increases due to Joule's heating effect, because H equals to I square RT, remember? T is the time. Now, this is Joule's heating effect. Now in this video, keep it till here. This was the last sum. In the next video, we'll solve the numerical from the next part. Till then, take care and be safe. And if you like the video, do subscribe and share with your friends.